Hello everyone, I am Vibha Kumar. I am from Kite Group of Institution. I am a student of Computer Science Engineering with Artificial Intelligence. Today I am here to tell you something about multiplication algorithm, which is used to multiplication of two sign numbers in binary form, and for which we use Robertson algorithm, and it is under my video assignment in subject computer organization architecture, and we will learn about this method by our PPT. Robertson method. Multiplication of two fixed point binary number in sign magnitude representation is done with the process of successive shift and add operation. In the multiplication process, we are considering successive bits of the multiplier, least significant bit first. The sign of the product is determined from the sign of the multiplicand and multiplier. If they are alike, sign of product is positive, else that will be negative. We will learn about Robertson method by its flowchart, because that will be easy for us. As you can see, the flowchart is visible in our screen. In this flowchart, we will see the multiply operation of Robertson method. In this, as you can see, we will store our multiplicand in B and our multiplier in Q. Now we will initialize our accumulator, which is shown here by A is equals to 0 and E is equals to 0. Here sequence counter will be stored. We will store n in sequence counter, and n will be the number of bits in the queue which are given to solve. Now we will see the least bit of q. If it is equal to 1, then we will do A is equals to A plus B. Here A is accumulator and B is multiplicand. Then we will go for shift next step, in which we will do shift right of the order E and Q, and then we will decrement the sequence counter. If the least bit of Q is equal to 0, then we will do direct shift right of EAQ and decrease the sequence counter value. Now we will see for the value of sequence counter. If it is equal to 0, then we will end the process, and if it is not equal to 0, then from starting we will do same as we have done. We will go for 2 checking least bit of q. If it is equal to 1, then we will perform A is equal to A plus B, and if it is not equal to 1 or it is equal to 0, then we will do as we have talked. And in this way we will complete our multiply operation. Everything is written in this page, what we have learned in this flowchart. You can see it here if you have any doubt. Now we will learn about Robertson method by example. That will help you to get more to know about this. Now here you can see we have to perform 23 into 19, which is our normal representation, numeric representation. First of all, we will for solving this, first of all we will convert the value of 23 and 19 in the binary form. Then B, as you can see, B is equals to B. 23 will be equal to 10111, and 19 will be equal to 10011. In the binary form, we will store the value of 23 in B, which is multiplicand, and the value of 19 in multiplier Q, which is equal to 10011. Here the value of number of bits is equal to 5. That will get stored in the sequence counter equal to 5 here. Now we will do our process which we have learned in flowchart. Here accumulator, we will initialize our E is equals to 0 and A equals to 0, and here Q is, as you can see, Q is equals to 10011. Q is equals to 10011. We will first see that what is the value of least significant bit of Q. Here we can see that here value of least significant bit is equals to 1. Then we since it is equal to 1, then we will add a plus b, and here a is equal to 0 and b is equal to 1 0 triple 1. The addition of a plus b will be equal to 1 0 triple 1. Now we will perform shift right operation, and after performing this operation we will get the value of 0, a is equal to 0 1 0 double 1, and the value of q will be equal to double 1 double 0 and 1. Now we will decrement the value of n. After the decrement of value of sequence counter, or n is equal to 5, we will get n is equal to 4. Now we will, since the value of sequence counter is not equal to 0, we will again perform our all the steps. Here we can see the value of qn is equal to 1. Then we will we will perform shift right operation of eaq, and we will get e is equal to 0, a is equal to 1 triple 0 1, and q is equal to 0 double 1 double 0. Now again we will decrease the value of sequence counter, or n is equal to, and or the value of n, and we will get the value of n is equal to 3. So we will again do all the steps. Here we can see qn is equal to 0, and to qn is equal to, since it is equal to 0, we will add a plus b, and then perform shift right operation. After that, again after decreasing the value of n, we will get the value of n is equal to 2. Then again we will do all the step. Here we can see qn is equal to 0, qn is equal to 0, and then again we will do shift right operation, and we will get e equals to 0, a is equals to 0 0 1 0 0, and q is equals to 0 1 0 1 1. Again we will decrease the value of sequence counter, and we will get the value of sequence counter is equals to 1, and we will see the value of least significant bit of q. We will get 1, it is 1. Then we will perform a plus b, and after that we will perform shift right of eaq. We will get the value of e equals to 0, a is equals to 0 double 1 0 1, and q is equals to 1 0 1 0 1. Now again we will decrease the value of sequence counter, which will go n is equals to 0. Since we have got n is equals to 0, we will end the process, and our final result of multiplication will be stored in a and q, which that you can see value of a and aq is equals to 0 double 1 0 double 1 0 1 0 1, which will be equivalent to the 23 into 19 in the normal form. Thank you.